Do rock.
All right, guys. So we're looking at parallel and perpendicular lines. A lot of what we do today, guys, is just talking about the concepts behind it, and then we're just proving them with proofs, why they work. So the transitivity of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So I'm going to show you what that really means in the drawing, but we're going to do a proof to prove it, that it's true. So what it means in this drawing exactly is if I know that L1 is parallel to L2, and if I know that L2 is parallel to L3, then obviously L1 and L3 will be parallel. That's what it's saying. Now, what we're going to do is we're going to prove that right here, that they're going to be parallel. All right, so first things first. The given is that L1 is parallel to L2. I already have that marked. And L2 is parallel to L3. I already have that marked. The reason? Given. Now, how do I know? So you have to remember that we know lines are parallel. How do I know from knowing that lines are parallel, angle 1 and angle 2 are congruent? Here's angle 1. Here's angle 2. How do I know that they're congruent? Yes? Yep, they're corresponding angles. Corresponding angles. Okay. How do I know that angle 2 is congruent to angle 3? Because look, we're told that L2 and L3 are parallel. That's in our given. So they're also corresponding. All right. This one's a little tricky, so be careful. How do we know angle 1 is congruent to angle 3? The way we get it is by looking at the previous information. Transitive property. Excellent. It's transitive because we see that angle 2 is part of 2 and 3. So angle 1 is obviously congruent to angle 3. Now, since we now know that angle 1 is congruent to angle 3, how can I say that L1 and L3 are parallel lines? Yes?
I don't think this is right, but would it be same side exterior?
Mm-hmm. This one's on the inside. This one's on the outside. And remember, same side exterior, add up to equal 180. We don't have anything that's mentioning adding up to equal 180, so be careful about that. Okay? Yeah, Joe.
Reflexive?
Nope. Reflexive is used when we say like angle 1 is equal to, or angle 1 is congruent to angle 2. Measure of angle 1 is equal to measure of angle 2.
Addition.
No addition.
Subtract.
Again, guys, let's pay attention.
Corresponding.
We know that the two angles are equal to each other. So how do I say that my lines are parallel? Because they're corresponding angles, and it's the converse. So corresponding angle converse.
But
Remember, if we go from knowing angles are congruent to lines being parallel, it's going to be blank converse. If we know from knowing angles are congruent or adding up to equal 180, that's better. Then we have to go from, it's going to be something blank converse. Okay? Questions? All right. All we're doing is proving that this is true. Oh, perpendicular lines.
yes.
So property of perpendicular lines. If two coplanar lines are perpendicular, to the same line, then they are parallel to each other. This is only true if the lines are coplanar. Who remembers what coplanar is? Yes. Lie on the same plane. Excellent. All right. I know my first line is given. All right, I'm going to mark it. L1 is perpendicular to L2. And L2 is perpendicular to L3. That's what we're told. So the question is, how do we know that angle 1 and angle 2 are right angles? What is telling me that they're right angles? Yeah. Good. So it's definition of perpendicular lines. That's how we know they're right angles, because perpendicular lines make right angles. So I can say, yeah, angle 1 and angle 2 are right angles. How do we know angle 1 is congruent to angle 2? We can't say corresponding. We can't say corresponding because we don't know these lines are parallel yet. No. Yes. Not perpendicular lines. So what it's going to be, we know that angle 1 and angle 2 are congruent because it's definition of right angle, since right angles equal 90 degrees. All right. So it's definition of right angles. Because we have right angles, and all right angles equal 90 degrees, they obviously are congruent to each other. Yes?
Isn't it basically the same thing though? Isn't it?
No. What do you mean it's the same thing?
Because corresponding to each other. Because they're corresponding lines.
But it's not corresponding because we don't know these lines are parallel yet. We're about to prove that they're parallel. See?
Math class.
All right. How do I know L1 is parallel to L3? Steven?
Huh?
How do I know L1 is parallel to L3?
Because of corresponding.
Corresponding angle compass. Because we proved that 1 and 2 are equal to each other, because they're both right angles, we can then say the lines are going to be parallel. All right? Because corresponding angle converse. Any questions? All right, here we go. Round 3. Last proof. Second property of perpendicular lines. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Whoops, I had to move down. All right. So let's see what we can see. Given. Let's get that out of the way. Now I'm going to mark up what the given is really telling me. The given really tells me L1 is perpendicular to L3. Then the given also tells me L1 is parallel to L2. That is what I'm being told.
Anthony, was it
And what's number 2?
the definition of perpendicular lines?
Good.
I'm getting the hang of it.
Now number 3 is tricky.
No, it's not.
Yes, it is. So, number 2, angle 1 is a right angle. It's definition of perpendicular lines because we're told that these are perpendicular. So that's why we know this is a right angle. Right? How do I know angle 2 is a right angle?
Transitive.
Parallel. Corresponding.
Yeah, corresponding.
Because it tells
Because
us
these
that-
lines are parallel.
And it tells us.
What?
It tells
It tells
us.
us that they're-
Yeah, it tells us.
Yeah, because it tells us parallel, we can then say these are corresponding. Excellent.
I thought it was wrong.
No, I was really happy.
You're smiling.
I wasn't like, you suck. All right, now the last one. How do we know L2 is perpendicular to L3? Be careful again. We're told that it's a right angle. So how can I say they're perpendicular then? What do we know? Yeah.
Is it corresponding again?
No. No, we're being asked if two lines are perpendicular. That has nothing to do with corresponding.
Thank you.
Come on, guys. How do I go from knowing that this is a right angle, angle 2 is a right angle, to now knowing that those are perpendicular? Definition. That's a good start. Of
Right angle?
a right angle.
Yeah, so-
All right, we're told that we have a right angle. We just proved that it is. And right angles make perpendicular lines. All right. Any questions? All right. So your homework is going to be text page 143, 1, 4 to 10, and 14 to 21. It should be on the next page. It is the very next page. It's all that. All right. Let me turn off the recording.